There we go. So of course, we started out with introducing just sets. We looked at the different terminology, and we just kind of got a basic start on Venn diagrams. We talked about what is an element, what's an improper proper subsets. We talked about a well-defined set. And then we got into a little bit more further discussion with, what is an intersection of sets, what the Venn diagram for that would look like. Mutually exclusive sets, union of sets, and also, of course, the Venn diagrams for them. And then the very last thing we had discussed was the cardinal. The cardinal number was this little one here, just to show you how to calculate the cardinal number for union or intersection of sets. And we'll do a couple examples just to make sure you guys are comfortable with that. And the last part we had talked about was the complement of a set. So complement of the set is basically, again, if you look at the definition here, we're basically saying it's an element X in your set where the X is going to be in your universal set, but it is not going to be in the set A. So when we're talking about complement of set A, we're basically saying, you can almost think of this as a negation that we had talked about in logic. So basically what we are saying here is that whatever is in set A cannot be in the complement of set A. So as long as it's part of the universal set, but it just cannot be what belongs in set A. And we had done a quick example of that, before we had dismissed class on Wednesday. Sandra, would you please go ahead and turn your video on? So the next part that I wanted to highlight was, again, cardinal numbers for the complement of a set. So the idea is, if you take the cardinal number for set A and add it with the cardinal number for the complement of set A, those two numbers total should give you the cardinal number for your universal set. So basically the complement and the original set themselves are going to add up to give you basically all the elements that will be in the universal set. And, and then they're just basically changing this formula, or you can say rewriting it, where they're saying, okay, if you wanted to calculate the cardinal number for set A, if you know what the cardinal number for the universal set is and the cardinal number for the complement of a set is, you can actually subtract the complement set from the universal set to get you your cardinal number for the original set. And of course you can reverse that transaction between the cardinal and the original set itself. So just kind of showing you how these two sets are connected basically with each other. And you've got an example over here that you can kind of look through. But let's pick an example from our textbook over here, just to give you guys a little bit more practice. Trying to see, most of these are actually getting into a little bit of a different discussion. So maybe something what we had done last time. So we had worked on example 10. Let's do number 16 over here. So here are your instructions for number 16. Trying to get it all on one screen so you guys can see. Alrighty, so looking at number 16, so they're telling us basically that the universal set is this one right over here, which has all the days of the weeks, right? Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday. They're telling us A is defined as Monday, Tuesday, Wednesday, Thursday, Friday, so all the weekdays. And then B is defined as Friday, Saturday, Sunday. So you can see in number 16, they're asking us to find A intersected with B prime. So you can see number 16 is saying A intersected with B prime. So, think about this. Set A is already defined for us right over here. but we're talking about B prime. So I want you guys to take a minute, think about what B prime should be, and then send me your answers through chat like we normally do. So just have your answer ready. Don't send it to me just yet. And I want to see how you are defining the B prime set. So let's make this here about B prime. What do you think the B prime set should look like? So just have your answers ready. And when I ask you to, only then send me your replies. Alrighty, so get your answer ready. Type it in the box. All right, guys, let me see what you came up with. Okay, so we're looking for B prime. I've got Friday, Saturday, and Sunday, Friday, and Friday. Okay, so that's Logan, Brandon, Idali, Roman, Riley, Nicholas. Okay, so remember I was asking you to define B prime. I'm not sure if you guys are giving me the answer for the intersection or what, because there should be more than one value in there. And then Idali, you went with Saturday and Sunday. So remember again, when we're talking about B prime or the complement of a set, so when you are talking about the complement of a set, and again, you can kind of look at the Venn diagram. So since this is set A, we are saying everything that is in set A cannot be in complement of set A. So that's the A prime. So that's why you will see we are shading inside the rectangle, but outside of the circle for A, because the complement of a set means all the elements have to be part of the universal set, but they cannot be part of the original set A. So when we're talking about B prime, since B prime has B itself has Friday, Saturday, Sunday, that means if you go and look at your universal set, so from the universal set, since Friday, Saturday, and Sunday are part of B, I cannot use them. So that means I can only use Monday, Tuesday, Wednesday, and Thursday in my B prime set. So when we are talking about the complement of a set, so again, like I said, since set B includes Friday, Saturday, Sunday, which means B prime cannot include those days. And you're always looking at the universal set, not set A. We have nothing to do with set A when you are trying to come up with the B prime. So look at the universal set and remove all of those elements which were part of set B, and then whatever is left behind becomes your B prime. So first thing you would have to do in an example like number 16 is define your B prime, and then we are ready to talk about the intersection between A and B prime. So this one, of course, here is where we look for, what's common between set A and what's common between set B prime. And that's what we are going to put in the intersection of this. Okay, So now I want you to give me the answer for the intersection between A and B prime. So what do you see common between A and B prime? And that's what we are going to put in this set here. So get your answers ready. I'll give you about 30 seconds to type your answers in, and then let's see what you come up with. So A intersected with B prime. Okay, so get your answers ready. And let me see what you came up with as the intersection. All righty, so let's see. Brandon, Monday, Tuesday, Wednesday, Thursday, Monday, Tuesday, Wednesday, Thursday, Dolly. Okay, Roman, you went with Friday as your intersection. Logan, Monday, Tuesday, Thursday. Nicholas, Monday, Tuesday, Wednesday, Thursday, sorry. Cynthia, same thing. Wendy, you also did intersection as Friday only. And then Riley, you've got Monday, Tuesday, Wednesday, and Thursday. So Roman and Wendy, can you kind of tell me what you guys were thinking and why or how you came up with Friday as your answer?
Friday is the only common one between A and B. So that's kind of what I was thinking.
Okay, but remember, you're not using set B, you're using the complement of set B, because you can see how this is about B prime, right? Not just set B itself. Because look at that, you've got B prime, right?
Right.
Yeah, so since you went with A and B, that would be the correct answer. But since they're specifically asking us for B prime, you can see how that would be incorrect. Wendy, what happened with you?
I kind of went the same way like Roman did.
With the A and the B?
Yes.
Okay, so I'm glad that we caught you guys doing that, because as you can see, that prime is, you know, just a little small tiny mark, but you have to be really careful about how your question is written down, because you can see this is what the intersection between A and B would look like when they're just using the original sets A and B, right? But here you will see with that little prime mark next to B, that kind of changes our set that you are looking at. And that's the same thing that's even happening in number 15, because they're asking you to use A prime, which is the complement of set B, A, with the union of set B. You know, here they're just asking you to define what A prime and B prime would look like, but then the last two questions are asking you to actually do union or intersection. So just be very careful with how the notations are written down, because you definitely don't want to get confused and, you know, come up with the wrong answer. Sorry, I didn't mean to erase that guy. All right, let's go ahead and put our answer in. So between A and B prime, you can see Monday, Tuesday, Wednesday, and Thursday are going to be common between those two sets. So all 4 of those days is what is going to make this union. So this will be your final answer for number 16. So like I showed you, you know, you kind of have to do this step by step. First, define what your B prime is going to be, and then come up with the intersection for your sets. All righty, guys. The next type of examples we are getting into, I don't know what's wrong with my pen today. It just does not want to write too well. Now we're actually getting into how you can shade, you know, different areas of your Venn diagram depending on what set you are looking at, or what kind of intersection or union you are looking at. So this one here, they're not actually going to specifically define what A and B are. They just want to see if you understand how the shading of your Venn diagrams work. So this one is asking you to find what would be shaded in the Venn diagram if you were looking at set A intersected with set B prime. So we are talking about set A, which is of course going to be, the entire circle for set A. So again, we're looking at part A over here, and that's intersected with B complement. So remember, B complement is everything that is not in B but outside of it. And that's going to be, everything in the universal set, just not in set B itself. So come on, buddy. Okay, so everything in the universal set would be everything that is outside of set B, just not, inside the circle of B. And you can see they're kind of showing you here by using the horizontal lines to show that, we're shading set A because that's the first part of our intersection. And then, we're using the vertical lines to show the complement of set B. So you can see A intersected with B prime, the only place where anything is common, okay, is going to be right where the horizontal and the vertical lines meet, right? So it's going to be right inside of the circle A, but it's not going to include that overlapping region between A and B, right? Because this area here, okay, it's not letting me do what I want to do. So this area over here is also common with set B, right? So we cannot use that overlapping area. So the only place where your two lines are intersecting is going to be right here in set A, not including the overlapping region. And you can see that's why we have shaded this little part over here. So that's what they're talking about in, when we're talking about shading these Venn diagrams. How do you find that common area, where we're looking at these intersections and unions? If you look at the part B example here, they are talking about finding A union B prime. So you can see that over here again, we're talking about A union B prime. So we're still talking about the same sets, but now we're talking about union between set A and between set B prime. So that's going to be, obviously everything outside of set B. So when we talk about union, you will see how different this Venn diagram looks, because that of course means you're including everything in set A and you are including everything which is in complement of set B. But you will see here, we obviously end up including the overlapping area also. And remember, that was the idea behind the union of our sets, because we said it can be either in the first set or in the second set or in both of them. So just by changing your intersection to a union, you can see how different your Venn diagram ends up looking like. So just comparing between the intersection and the union. So this is kind of what, we're talking about in terms of shading Venn diagram. So let's take a look again at a quick example over here. And you can see your instructions here. They're saying use a Venn diagram, like the one in this figure 2.15, to shade the region corresponding to the indicated set. So how about we look at number 26 over here. So 26 is talking about A complement intersected with B complement. So again, we're going with complements on both of them. And you can see this is the general figure over here with the overlapping A and B sets. So let's just recreate that over here. Let's see. So we need a rectangle for our universal set. So this will be for our universal. And then we need two overlapping circles. So one for set A. Well, then let me move that. Not really. Okay. Well, you get the idea. It's not going to look perfect, but that's fine. So this is going to be set A. Well, let's put it inside. And this is set B. So think about this. Where is our A complement going to be? And again, I just want to know which area is going to be the A complement. So where would you shade for the A complement? And you can either unmute your mic or you can put it in chat, whatever you're comfortable with.
Anything that's not A.
Anything that's not A. Very nice, Adalhi. So maybe this guy needs new batteries. I'm not sure. Let me see if it will let me pick a different color over here. So anything that's not A. So, you know, of course, that's going to be everything in the universal set, as long as it's not in the circle for set A. So of course, that would include, you know, that non-overlapping part of circle B, and then, you know, everything else in the rectangle. So that's A complement. Now, what do you think the B complement is going to be?
Everything but B.
Very nice. Exactly. Everything but B. So how about, I guess we'll use orange for that. So everything but B. So that's going to be our vertical lines, which means, of course, it will include everything in set, the universal set, and, you know, the non-overlapping part of set A. So whatever is not in set B. So, okay, so now think about this. Now we want to know what will be the intersection between the complement of set A and the complement of set B. So where are you seeing the overlapping happening between the two complementary sets, or the complements of the two sets?
In the universal section, but not A or B.
Very nice. Yeah, because you're only seeing the overlap happening outside of the circles A and B. So that's what your shaded area is going to be. So, you know, in the final result, you should basically have all your shading on the outside. So just everything in the rectangle, just not including any of the circles, and that's what you are looking at as your solution set, or, you know, your solution to this shading. And you can see they've given you different examples over here, just to give you different combinations of, you know, the complementary, non-complementary sets, and, you know, how you would come up with that. So you've got a couple different examples like this in your homework, where, you know, they'll give you different choices. You will have to choose which one is your shading, you know, the correct shading. So just use this process of horizontal and vertical lines. So again, wherever you see both of them coming together will give you the intersection. And when it's union, remember, it can be part of one set or the other set, or they can be in both, and you have your the shading you are looking for. So just to show you, when we change this from an intersection to a union, like number 25, what that shading ends up looking like. So you can see how different this one is, because in our example, the shading was only going to be in the rectangle, but both the A and the B circles would have been blank, right? They would have been white, using this color scheme. But you can see when we talk about the union, that's because you can have anything in circle A, because remember, anything that's in circle A is a complement of the B set. Anything that's in circle B is the complement of the A set. So both of them are shaded, except just the overlapping area because, obviously, that's not going to be part of the complements of the set. So that's why that area stays blank, but everything else is shaded. So just a difference between your union and intersection between these two sets. All right, guys, so we want to build up on this idea. Okay, Sandra. So there, and I kind of like this that they're getting into is just showing you that comparison or almost the similarities, if you will, between our logic and the set theory that we just talked about. And, we kind of talked about this last class also. So you can see your union symbol in the set theory is basically coming from the same concept of the disjunction or the or between your logic symbols. The intersection is coming from the conjunction or the and. The complement is coming from the negation. Because remember, whatever is in the complement of the set is not in the original set, just like with negation. Again, if we kind of look at an example of it is raining, if that's the original statement, the negation is going to be it is not raining, right? So whatever is in the first sentence is not going to be in the second sentence, and that's kind of how the complement works. And this is the most interesting part because we didn't really talk about this, but a subset is actually based on the conditional statement of if then, because we are saying if these elements are in set A, then we can say set A is a subset of, the universal set or, whatever the example would be. So your subset is actually coming from the conditional statement. So it's really very interesting to see how the concepts of set theory are based on the concepts of logic. And then, they're kind of giving you another breakdown of kind of just showing you how you can use the idea of a union between two sets by using our logical symbolism, basically. So you can say when we're saying X is an element of the union of two sets, we're basically saying X can be an element of set A or X can be an element of set B. Here we are saying if X is an element of the intersection of two sets. So if X is an element of the intersection, that means X has to be in A and X has to be in B. Complement, of course, we are saying if X is in, if X is an element of the complement of A, then you can see we're using negation here. So we are saying X is not an element of A. So that's your complement with the negation. And then for the subset, we are saying A is a subset of B. That means if X is in A, then X is also in B because, obviously that means A can be either a proper or an improper subset. It doesn't matter. If X is in A, then automatically it means X is in B. So that's your if-then statement comparison that they're kind of bringing in over here. So it's really, really interesting if you think about it, how these two concepts are kind of tying into each other. All right, did you have any questions about that? Okay, so I wanted to look at a couple of these examples where we can use Venn diagram to actually do those calculations, because remember when we started this section, we were talking about how many students voted for increasing. Hey, Brendan, that's a very cute class companion you have up there. So you can have, and I am always okay with pets showing up on your videos because I'm not allowed to have a dog. My mom will kill me if I get a dog. So I enjoy seeing all of your pets. So just to see, we were talking about college students voted on increasing the alcohol tax, or college students voted on, what was that other one? I think gasoline tax or something like that. So how we can actually use Venn diagrams to help us come up with all of these different numbers. So the first example I wanted to look at is number 32 over here from your textbook. Okay, so let's take a look at 32 over here. So this one is talking about in a recent health survey, 700 single men in their 20s were asked to check the appropriate box or boxes on the following form. So they can check, I am a member of the private gym, or I am a vegetarian, or they can check both boxes, obviously. So when the results were tabulated, we had 349 men who checked the gym box, 101 checked the vegetarian, 312 were blank, which means they didn't check any of the boxes. So they're asking us to draw a Venn diagram to illustrate the results of the survey. And then the second question is asking us what % of men were both members of a private gym and vegetarian. And they didn't actually tell us that in the results that they tabulated over here. So then we have to find out what percentage of men were members of, both, or basically they checked both the boxes. So let's go ahead and take a look at this. We probably want to write all these numbers down. Let's bring it over here. Okay, so we have a total of 700. And then they told us 349 checked the gym box, 101 checked the vegetarian box, and 312 left it blank, or basically they checked no boxes. Okay, so this is the information that we have. Does it let us do rectangles over here? Okay, so of course we always start out with our rectangle for the universal set. And then they want to know how many of them checked both the boxes. So there's definitely going to be some overlap over here. So we'll do one for the private gym, and we'll do another one for the vegetarian. Okay. Okay, so this will be for the gym, and this will be for the vegetarian. So now the idea here is we know there's a total of 700 men, right? So that means everything that you are going to have inside the rectangle has to add up to 700. So that means, when they're telling you there are 349 going to the gym, remember that means 349 is including everything in the G circle, right? So that 349 is actually going to be, and I'm going to use a different color here, is going to be everybody who's outside and everybody who's inside. So together they make up 349. And that's going to be the same thing with the 101 for the vegetarian. So that means everybody who is in this circle and who is, in that overlap is also going to add up to 101. So we have a little bit of overlap happening in there. Now, the only one answer that we are almost certain about is the 312 men who left their answers blank, right? They didn't check any boxes. So since they didn't check any boxes, that means they don't fall anywhere within this circle. And this pen is really driving me crazy today. Okay, so the 312 will actually go outside over here, because since they left everything blank, they do not fall into any of the boxes. So the 312 men, we're actually going to put them outside the circles, but obviously still within the rectangle because they're still part of those 700 total men. So if you think about this, from the 700, 312 basically did not vote, right? So how many does that leave us with? Right, I'm seeing an answer coming through. Very nice, Brendan, 388. So that means within our two circles and the overlapping area, all of that number should add up to 388. Is this making sense, guys? Why we put the 312 outside the circles? Is everybody understanding that part? Because they did not vote for Jim or vegetarian, right? So they don't belong inside the circle. So they're outside the circle, but obviously still inside the rectangle. So that means inside the circles, you're going to have 388. Now, you know, if you just add 349 with 101, you will see it adds up to 450. But we obviously do not have 450 inside the two circles because we only have 388. So this is how you actually know that you are going to have an overlap between the two groups. So this is actually where we get into those calculations for cardinal numbers. So let's look at that formula just to remind you guys. Where did it go? This one over here. So let's take a look at what information we have. So we know each individual group because we know if we think of A as being our group of gym members, you can think of B as the vegetarians. We don't really know the intersection, but we can find out the union. So we will actually need to rearrange this formula a little bit. What we're going to need to do is bring this intersection on this side and move the union on the inside. So we're actually just going to rearrange this formula a little bit to satisfy our example over here. So let's do the cardinal number between the intersection of gym and vegetarians, which will be number of gym members plus the number of vegetarians minus the number of our union. Okay, so we know that we have a total of 349 gym members, so that will go over here. We know there's a total of 101 vegetarians. Now the union, we have actually already done the calculation because we know that's going to be our 388 over here. But if you want, we can do that calculation in here. So 700 minus the 312, which gives us the 388. So that's how we came up with our union value. And then once you calculate this, you should be able to come up with what the intersection should be. Okay, so Brandon, you came up with 62. So you're basically taking 349 plus 101, which as I told you was 450. And from that, you are subtracting 388. So very nice. You're coming up with, yeah, very good, Brandon, with 62. And remember, this is the intersection. So your 62 is actually the number that's going to be in here. So we actually have, come on, buddy. There we go. So we actually have 62 in here. Okay, I don't want that. Wow, this guy is really not letting me do anything today.
Couldn't you do this an easier way instead of doing all that though?
How would you do that?
349 plus 101 plus 312 minus 762. It's the same thing.
Okay,
So
so
just-
you're just adding the three.
All the three totals minusing the 700 men. It's
Okay.
still 62 because it
Alright.
equals when you add all three of them, it's 762.
Yeah, so that would be more than your total men. So I can see what you're doing over there. Yeah. So in this example, it definitely works out. But again, just remember, it depends on what information was given to you, what was shared with you. Sometimes that will work, sometimes it will not. But in this example, it definitely works out. Now, the question in the example is just asking you to find out what percentage of these men were both members of the private gym and vegetarian. So as far as this example goes, they are only looking for 62, but there will be some examples where they will want you to complete your entire Venn diagram, right? So they will ask you to find out the total number in each of the circles, the intersection, and what's outside. So all you have to do is figure out how many men only selected the gym. So that is where you would take your total of 349 and subtract the 62 from it. Okay, Riley, yeah, I was wondering what happened. So to calculate your gym members, you are basically going to do, and again, hopefully if it will let me type my answer in here, you are doing 349 minus the 62, because remember, that's the overlapping area, and that's what you are going to have as only the men who selected gym membership and did not select the vegetarian. So that would be 287 is what it comes out to be. And then if they asked you what was the men who only selected vegetarian and no other box, that would be the same thing. You would do 101 minus the 62, because again, that's the overlapping area. And what will that come out to be? 39. And then once you add 287 with 39, with the 62 and the 312, that will be just a good way to check and make sure you get 700 as your total single men who took part in the survey. So just kind of keep that in mind, depending on what your question is, because some of them will ask you to complete the entire Venn diagram and fill in all the specific blanks and stuff in there. And then based on that, answer your questions. But I'm really glad that Brendan, you brought up that point, because in this example, like you said, you can add the 312 with the 349 101, and you can see there's an overflow of 62. So that 62 is going to be part of your overlapping area. Okay, question on this one, guys? All right, let's do a little bit of a different type of an example next. This one is number 44. Okay, so let's look at the instructions here for number 44. This one is talking about determine how many cards in an ordinary deck of 52 fit the description. And they are saying if you're unfamiliar with playing cards, at the end of section 3.1, they are giving you the description of what a standard deck would look like. So I wonder if this will open for us. I think it actually shows you an image. Come on, buddy. There we go. So, of course, you're just going from, if you go, I guess, higher cards, aces, all the way to, 2 on the deck of cards. You've got your 4 suites, and then, each one of them have 13 cards in them. So when you add 13 times 4 or multiply, you end up getting 52 as your total. So keeping those cards in mind, and, of course, thinking about that, they want to know, basically determine how many cards in an ordinary deck of 52 cards, will you come up with what will be your description over here? So number 44, they're talking about face cards or diamonds. So remember, when they're using or, they're talking about a union. When they say and, they're talking about intersection. So again, bringing those concepts from logic into our set theory. So face cards and diamonds. So again, does anybody just want to help us out if you're not familiar what a face card is?
King, queen, jack.
Yeah.
King, queen, jack. Do we use aces in that?
Aces are face cards.
Aces are also face cards. And see, and that's why I was kind of hoping some of you would come up with an answer, because, you know, if you are unsure, then think about how your calculation will change, right? So how many total face cards do we have in a deck of cards then, thinking about all the suites that are available? What would you say is the total number of face cards that we have?
16,
16?
because it would be the 4 face cards in every suit.
Okay, so okay. And then how many diamonds do we have? You know,
13.
I am thinking. Okay, now you guys have me confused. Is ace a face card?
It's not a face card because ace can also be considered one, and a face card only is the face because it describes a person. That's what I
Right.
was.
Yeah, that's a
That's
good
like-
way-
Certain house rules.
Yeah, it's kind of a biased opinion, I guess.
Yeah,
Do they actually? They're not really showing us an ace
It's-
over here, but
what I've always known was
Uh-huh.
because ace doesn't hold a direct numeric value, like specifically showing 1, 2, or 3 or whatever,
right.
that it belongs to the face, because it can, in gambling sense, can be considered the highest card.
Right, right. Okay. We are going to ask Google to help us out. Let's see what Wikipedia has to say. Okay, so they're definitely showing us the king, queen, and jack. And that's what they are saying. Now, some of them. Okay, this is just a suite.
I guess you can decide what the face cards are.
Yeah, and I
Sure,
almost
but-
want to say I'm not sure about the ace, because it seems like they are kind of talking about,
Yeah.
you know, the actual existence of a face and an ace. And honestly, I think sometimes it comes down to your deck design, what it would have. But I guess to avoid confusion, let's kick the ace out, because I honestly am not sure if the ace is part of the deck or not. I mean, the face card or not. So that would actually change our calculation. If we only did king, queen, and jack, you know, so that's 3 times 4 will only give us 12. You know, of course, we have 13 diamonds in the card. So what do you think our total number of cards should be here for this one? Yeah, and some of the decks do have a joker, but again, it comes down to, do we really count the joker as part of the suite? Because that's what I have been told, not to count the joker. So, you know, it kind of puts you in that gray shade. So we'll just do aces to 2, you know, as our each suite, and that's times 4. And Okay, so yeah, Brandon, I just saw your message that aces are not face cards. So what do you think our total is for the number of cards over here for face or diamonds?
25.
25? Anybody who wants to dispute that claim? Come on.
Some
Brandon.
of the face cards are diamonds, so we would have to figure out the difference or what the, I guess, the intersection would be. first.
Very nice. Yeah, so kind of like what we just did with the vegetarian and the gym example. So since they're asking us for or, we know that's a union. So you're actually falling back on that same formula we just used. So that's total number of face cards plus total number of diamonds. But then from this, you have to subtract any overlapping area. So that would be the intersection between the face and the diamond. So we've got 12 face cards, 13 diamonds. So how much will be in the overlapping area between face cards and diamonds? Between overlapping between face cards and diamonds, Brandon, you're thinking 4?
Yeah, there's only, oh wait, king, oh, there'd be 3.
3, yeah, because the only repetition between the two groups would be the 3 king, queen, jack cards, right? So you are actually subtracting 3. So that would be 25 minus 3, which I guess comes down to 22 as our grand total for how many cards we will have. So that should be a minus sign there. So does that make sense, guys, why we are subtracting that 3? Because again, if you think about the Venn diagram for this, and I'll do a very tiny one over here. So if we've got face cards and diamonds, you know, in that little overlapping area is where you will have the king, jack, and the queen in there. So since those 3 cards will be part of both the face cards and the diamonds, you need to subtract that to get our total of 22 cards. All righty, very nice. So since we are on the subject of face cards and diamonds, you will see on number 46, and let me move this slightly up over here. So you can see where they're talking about face cards and diamonds, you know, this is where they are talking about the intersection. You know what? Let me just save this before I make any changes. So this is now going to be talking about the intersection. So in this case, for number 46, you are actually only looking at this portion of your calculation. So the answer for this would be 33, just for number 46, because they're only interested in the intersection, so that overlapping area. So anywhere you look at, you know, where you have the word and, remember they are talking about intersection. Wherever you have or, they are talking about union. So you can see how different examples go back and forth between and or in this set of examples here. So anybody have any questions on this? Okay, and I think I've got maybe one more quick example over here. It's a little bit different than what we've done. Let's look at number 56. And you can see this is part of a concept question. So they are asking you if the union between A and B, so if A union B is an empty set, what is the relationship between sets A and B? So just take a minute to think about it. You've got A union B as an empty set. So what does that mean? Because remember, union means anything that's in set A or anything that's in set B, or anything in both. You put it all together and you get the union, but they're telling you A union B is an empty set. There are no elements in there. So what does that mean?
Both sets are empty, A and B.
Very good, because the only way a union can be an empty set if each individual set is empty. Very nice. So that means A and B are both empty sets. So since they are both empty sets, the union is an empty set. Because intersection can be different, right? Because with intersection, we talked about mutually exclusive. So if the two circles were separate, they had no overlap, we can say, well, the two sets are mutually exclusive and they have nothing in common. But union, even if they are two completely separate sets, we can just put all the elements together and come up with the union. So the only way your union can be an empty set if each individual set is an empty set. All righty, very nice. And you can kind of see that's what you have over here in 55, because they're talking about intersection between A intersected with B being an empty set. And that's because they are disjoint sets, or like I said, you can say they are mutually exclusive sets. That's why they're empty. But with union, the only scenario can be both being empty sets. All righty, perfect. So that actually were some examples that I wanted to show you from section 2.1. Now we're getting into a little bit more in depth with section 2.2 and with Venn diagrams in section 2.2. So this is where you will see a little bit more of these application based sort of examples here. So let me pull up an example. There's not really a lot of explanation going on in this, more like going through different examples and kind of helping us come up with the different numbers for each section and then answering our questions kind of thing. So let's take a look at our first example with 2.2. And I think the first example I have here is number 4. Alrighty, so this one is talking about a department store surveyed 428 shoppers and the following information was obtained. 214 shoppers made a purchase. 299 were satisfied with the service they received. They're asking us if 52 of those made a purchase were not satisfied with the service. How many shoppers did the following? So how many of the shoppers made a purchase and were satisfied? So I guess this would be both, right? How many shoppers made a purchase or were satisfied? So that's a union. How many were satisfied with the service but did not make a purchase? And how many were not satisfied and did not make a purchase? So you can see they're giving us some basic information at the beginning, but then you have all of these different questions coming up after that. So let's go ahead and write down all the information that we have on hand. Alrighty, so we know they surveyed a total of 428 shoppers. Okay, they're telling us 214 made a purchase. 299 were satisfied with the service. And then they are saying 52 of those who made a purchase were not satisfied. So out of the 214 who made the purchase, come on, buddy. This pen is not doing what it's supposed to do. 52 were not satisfied. Okay. Alrighty, so can you tell me what our two main circles should be in this example?
Satisfied and not satisfied with service.
Okay, so satisfied and not satisfied, wouldn't the not satisfied just be the complement of satisfied?
Yeah, I guess that makes sense.
Okay, so then in that case, what do you think the second circle should be then?
Purchase.
Yeah, so the two categories they're actually specifically highlighting for us has to do with shoppers who made a purchase and shoppers who were satisfied, and then they just had different combinations of those two groups, right? So those are actually your two main circles. Trying to move this guy, but he doesn't want to. We'll leave it as it is. All right, let's see. So we have our universal set. We have people who made a purchase and people who were satisfied. So let's see, they're telling us there's a total of 428. So again, just like we did with the single men example, everything inside the rectangle has to add up to 428. So they're telling us 214 made a purchase. Out of those, 52 were not satisfied. So we know everybody in the P circle has to add up to 214. Now, this overlapping area over here is going to be between people who were satisfied and who made a purchase, right? So where do you think these 52 people need to go? Because they made a purchase, but they were not satisfied.
P.
So will I put them in the overlapping area or P but not overlapping?
Oh, not overlapping.
Not overlapping. Very nice, Logan. Because remember, these 52 people made a purchase, but they're specifically telling us they are not satisfied. So to go in the overlap, you have to make a purchase and be satisfied. So that means this 52 people made a purchase, but obviously they're not happy. So can you tell me what number should go in the overlapping area then?
214.
But the 214 also includes the 52, right?
Oh, it's okay. 162.
Very nice. So the overlapping area here, guys, is actually going to be the 214 minus the 52. So for this area here, you are doing 214 minus 52. And what does that come out to be?
162.
162. All righty. So that means there are 162 shoppers who were satisfied and obviously they made a purchase. So can somebody tell me then what number we should have for only the satisfied shoppers? Because they're telling you there were 299 who were satisfied with the service, right? Logan, go ahead.
299 minus 162.
Very nice. So again, we need to subtract that overlapping area. So we know there's a total of 299 satisfied shoppers. That also includes these 162. So that's
137.
137. All right, awesome. So 299 minus 162 is 137. So that goes in here. So we know there's a total of 428 shoppers. So is this adding up to 428 within our three areas in the circle? Or do we have some people who did not make a purchase and who were not satisfied?
Yeah, we're at totals 351, I think.
Okay, so when you add the three numbers,
351.
okay, so 52 plus the 162 plus the one. Oh, come on, buddy. So Brandon, you said 351. Okay, my pen's not working, guys, so I'm actually using my finger to write these down. That's why looks a little, not very precise. Okay, so the total inside of the two circles and the overlapping area is 351, which means we still have some people from those 428 shoppers who did not make a purchase and, who did not, or who were not satisfied with the service. So can you tell me what that number comes out to be then?
77.
77. Okay, Brandon, I just saw your answer in the chat. So what you are doing here, guys, is you're taking that total of 428 shoppers, and from that you are subtracting 351, which gives you the 77. And these are the people who are going to be outside of the two circles, but still inside the rectangle. And then when you add all four of those numbers, of course, that comes out to be our total shoppers of 428. So what this is telling us is basically we have only 52 shoppers who were who made a purchase, but they were not satisfied with the service. So let's see if we can write this down. 52 shoppers who made a purchase, but are, not satisfied with the service. You have 162 shoppers who made a purchase and they are satisfied with the service. Can you tell me what 137 represents then?
Satisfied and made purchase. So just be satisfied without a purchase.
Very nice, because you can see the 137 is just in the circle S. It's not part of circle P, which means they did not make a purchase, but they are satisfied with the service. So that's what the 137 represents. And then the last number is 77, which is on the outside. Oh, come on, you are working right now. Okay, 77 on the outside represent no purchase and not satisfied. Sorry, again, that last part was my finger because my pen stopped working. So now that we have all the sections of our Venn diagram completed, can you tell me what our answer for part A should be? They made a purchase and were satisfied with the service?
162.
Very nice. That's the overlapping area. Very good. So part A is going to be 162. Okay, part B is saying made a purchase or were satisfied. So this is a union. They made a purchase or they were satisfied with the service. So remember, this is or, which means they made a purchase or they were satisfied or both.
$351.
Very nice. So that's actually going to be the total of the three regions inside our two circles. And we already added that up right over here. So that is your 351, because remember, this is a union between purchase and being satisfied. Okay, part C says they were satisfied, but did not make a purchase.
137.
Okay, so satisfied, but did not make a purchase will be the people just in the S circle without the overlap. Very nice. So 137. And part D, guys, is not satisfied and did not make a purchase.
The 77.
The people on the outside of the two circles. Very good. 77. Okay, so again, since I did not get a whole lot of participation from the rest of you, did this make sense? How we came up with these A, B, C, and D answers? Anyone who was not sure?
Yeah, it made sense.
Okay, because section 2.2 is just about completing the Venn diagrams, and then answering the questions based on that. So we'll definitely look at more examples. I know some of you just started with 2.1 homework, but obviously if anything in 2.2 does not make sense or you need help, reach out to me, let me know. But this is what we'll continue for our next class, is look at a couple more examples from 2.2 just to make sure you are feeling comfortable with these types of questions. And then we're actually not going to do a lot of in-depth with 2.3 and 2.4. I just want to go over some of the basic calculations for you, and then we'll get into chapter 3 after that. Okay. All right, guys, if you have questions, stay back and ask me any questions. If not, I will see you on Monday. So have a wonderful weekend, guys. Be careful. Stay safe, everyone. Be careful. Bye.